Have you ever really stopped to think about braces? I mean, really think about the biology behind them? Today, we're going to dive into the incredible hidden drama that unfolds every single time an orthodontist makes an adjustment. It's this amazing story of demolition and construction, and it's all happening right inside your jaw.
I mean, how is that even possible? It sounds completely nuts, right? You're pushing a solid object, your tooth, through an even more solid object, your jawbone. You'd think it would take a jackhammer. But it's not about brute force at all. It's actually a super sophisticated biological conversation, and we're about to listen in.
So the whole secret comes down to this constant push and pull, this little battle of pressure and tension. Every time a wire puts force on a tooth, it creates two completely different zones around the root. There's a pressure side, where the tooth is literally squishing up against the bone, and a tension side, where it's pulling away.
And here it is, the whole story in a nutshell. On that pressure side, the body gets the signal to clear a path. It calls in the demolition crew. But on the tension side, where things are being stretched, the body sends a totally different signal, fill in the gap. It calls in the construction crew. This incredible dance is what lets a tooth move safely through a bone. So let's start with the demolition side. How does the body know to get out of the way? All right, let's zoom in on that pressure side. The tooth is pushing, the ligament around it is getting squeezed, and the body basically gets a memo that says, hey, we need to make some room here. Get this bone out of the way. To do that, it calls in a very specialized crew. And who answers that call? Meet the stars of the demolition show, the osteoclasts. These are amazing little cells whose entire job, their whole purpose in life, is to dissolve bone. But they don't just wander around randomly. They have to be activated. They have to be told exactly where to go. So how do they get the message? Well, it's like a chain of command. It all starts with that squeeze on the ligament cells. They get stressed out and start sending out chemical signals, like little flares. And the most important signal, the one that really matters, is a molecule called rank LCAT. That's the green light. That's the final go order for the osteoclasts. So yeah, you can totally think of Rankle as the demolition foreman on the job site. It's the one with a megaphone, and when its levels go up, it's basically shouting, all right, team, time to get to work. Start breaking it down. But, you can't just have a demolition crew going wild, right? That would be a huge problem. So the body has this brilliant built-in safety check. It's a molecule called OPG, and it acts like a safety inspector. It basically runs interference by acting as a decoy. It jumps in and blocks the Rankel signal, making sure the demolition doesn't get out of hand. It's the system's emergency brake. Of course, our foreman Rankle doesn't work alone. He's got a hype crew. Other molecules, like prostaglandins and the cytokines, they show up and act like megaphones, amplifying the foreman's orders. They turn the volume way up, making sure everyone knows that yes, this is serious, we need to clear this path right now. Okay, so that's one half of the story, the demolition. But remember, at the exact same time, on the other side of the tooth, something totally opposite is happening. Over here, the ligament isn't being squeezed, it's being stretched. And that stretch is the signal for a completely different crew to get to work. And for this job, you need builders. Meet the osteoblasts. These guys are the master construction crew of the body. Their whole job is to come in right behind the moving tooth and start laying down new bone, making sure that tooth stays solid and secure in its new spot. And their process is just as elegant. It all kicks off with that stretch in the ligament. That stretch triggers the release of a bunch of different growth factors. You can think of these as the architectural blueprints for the project. The blueprints call in the osteoblasts, the builders, who then get to work laying down fresh, new bone. And if those growth factors are the blueprints, then deep inside each builder cell, you've got the master architect. Its name is RUNX2. Now, it's a transcription factor, which is a fancy way of saying it's the one that reads the blueprints and tells the cell's internal factory which parts to start making to build brand new bone. It's directing the whole build. So what kind of tools does this construction crew have? Well, they've got some pretty heavy-duty stuff. Powerful growth factors with names like BMPs and TGF-beta, these are the signals that don't just say build, they say build now, and build this much, basically ramping up the whole production line. So let's just take a step back for a second. The really crucial thing to get here is that this is not a random, chaotic process. It's an incredibly regulated system. You've got two completely distinct teams with their own signals and their own outcomes, all working on opposite sides of the same tooth. Let's really put them head to head. And this chart just lays it all out perfectly, doesn't it? On the pressure side, demolition, your primary cell is the osteoclast. The key signal, Rankle, and the outcome,
bone resorption, breaking it down. Then you look over at the tension side, construction. The primary cell is the osteoblast. The key signals are those growth factors, and the outcome, bone deposition, building it up. It's a perfect yin and yang, two opposites, yet perfectly synchronized jobs.
And get this all starts happening incredibly fast. We're not talking weeks. Within hours of an orthodontist tightening a wire, the body is already sending in enzymes to prep the site. And within a couple of days, the main demolition and construction crews are there in full force, hard hats on, ready to do the heavy lifting.
When you really step back and look at the whole picture, it's not just a battle or a construction project. It's more like a symphony. Every single molecular signal, every cellular action is perfectly timed and coordinated to achieve this one single goal, to move a tooth safely and effectively. And that balance is absolutely everything. I mean, think about it. If you only had the demolition crew, the tooth would just get loose and fall out. And if you only had the construction crew, it wouldn't move an inch. You have to have both working in perfect concert to literally reshape the jawbone as the tooth travels to its new home. I love this quote because it just hits the nail on the head. We think of our bones as these fixed, static, rock-solid things, but this gentle, constant orthodontic force flips a switch, and it transforms that bone into this living, breathing, dynamic system that can be reshaped with incredible precision. It is pretty mind-blowing when you think about it. Your body is orchestrating this unbelievably complex symphony of cells and signals, all just to straighten your smile. It really makes you wonder, doesn't it? What other amazing, invisible, microscopic marvels is your body pulling off right this very second? It's something to think about. Thanks so much for joining me.